Yes, I'd like to prove to you, which can be done rather short actually, this general simulation result that was given to you in the main lecture, that if you have something that follows a uniform distribution on the interval from 0 to 1, that is, from a simulation perspective, if you can simulate such ones, then you can achieve any kind of distribution if you apply the inverse of some distribution function g to such u. These observations coming out of that would then follow, in fact, the distribution, you say the g distribution. So that is kind of the simulation, basic simulation result. How can we prove that? Well, we can use the standard transformation formula that I have given to you in previous extra math videos. That general transformation rules expressed on densities would look the following. The density of the inverse of u applied in y would be, as it was expressed back then, would be the derivative of some w function of y, absolute value, and then the density of u applied to this same w of y function. And the w of y function is then the inverse of the transforming function. And since the inverse of the transforming function is capital G, the distribution function of some distribution, then the inverse of that simply is the distribution function of y. Then if we apply this, the derivative of the distribution function then becomes the density function of corresponding to capital G of y. And what is the density of the uniform between 0 and 1? Well, in fact, that is the constant 1. And basically, this is the proof that the density of those inversely, I should say, of these ones coming out there, capital G, inverse of u, becomes actually the y density, the density of y. So that means that this is how we can simulate from any g distribution. If we can simulate standard uniforms like that, we can use the inverse g to transform them, and we get something which follows the g distribution. Basically, that's it. Thank you.